Okay, hello all. So in today's video, we are going to discuss the fundamental theorem of arithmetic. The fundamental theorem of arithmetic. So to explain this, we will start with a real world example. So let's take the example of a block of wood. Okay, just a simple block of wood. And suppose we try to break it down into smaller and smaller segments, as small as we can go. So this is the smallest segment. Now let's take it further and break it down even further. Now from this again we will take the smallest segment and break it down further. When we do it continuously, we will reach a point where we will reach a smallest segment which can't be broken down further. This we call an atom. Now, even an atom can be broken down further into electrons, protons, neutrons, and other subatomic particles, but for now we will consider atom as the basic building block. So, in summary, all the things that we see in this world can be broken down further till we reach the point where we can't break it down further, which is called the basic building block of that matter, and it's called atom. So similarly, in mathematics also, we have a basic building block of all numbers. So let me erase this. And then we will take a number. Let's start with a smaller number, let's say 16. And when we try to break it down, the first thing that comes into mind immediately is 2 into 8. Now 2 is a prime number. We can't break it down further. But 8, we can again break it down. So let's do it. 2 into 4. Now again, these two 2's are primes. This 4 can be broken down again. So let's do it. Now we have reached a point where all the factors are prime numbers, which means we cannot break them down further because prime numbers are not divisible by any other number than the number itself and 1. So okay, to write it properly, we can write it as 2 in 2 raised to 4. Okay. So we have reached a point where we can't break it down further. Let's take a bigger number. Let's take 68. This can be written down as 2 into 34, which can be written down as 2 into 17. So to write it properly, we will write it 2 raised to 2 into 17. Again, so this 2 and this 17 are primes. We can't break them down further. So basically what the fundamental theorem of arithmetic says is that all the numbers can be broken down and expressed as a product of primes. So basically the prime numbers are the basic fundamental building block of all the numbers that we know. Of course, we are talking about only natural numbers. We are not talking about decimals because in that case, the 17 will be broken down into 2 into 8.5. So we are considering only natural numbers in this theorem. Okay, so now let's take the actual statement of the fundamental theorem of arithmetic and let's see if we can understand it now. So this is the statement. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So as we saw, right, 68 can be written as 2 square into 17, which is a product of primes. Every composite number can be expressed as product of primes. The second part it says is that this factorization is unique apart from the order in which the prime factors occur. So we can write it as 17 into 2 raised to 2 also. But apart from this order of the prime numbers, this factorization is unique, which means 68 cannot be expressed in any other way. It has to be 2 raised to 2 into 17 or 17 into 2 raised to 2. So basically, the fundamental building block of 68 is 17 and 2, these two prime numbers. And this is true for all numbers. You can break down any number and finally you will get a series of primes. And that is the unique combination. So 68 has 17 and 2. Similarly, we saw that 16 has only 2. There is no other way in which 16 can be expressed as a product of primes other than 2 into 2 into 2 into 2. So it is like identity. It is like an Aadhaar card or passport of that number, that it is unique. Okay, so this is the fundamental theorem of arithmetic. That all the numbers in the mathematical world, all the numbers can be expressed as product of primes. Basically, prime numbers are the building block of all numbers, and that way of expressing is also unique, so it gives the identity of that number. But what is the use of it? Okay, so the to understand the application of this theorem, we will take one example. So in this example, so it is saying that consider the numbers 4 raised to n, where n is a natural number. Check whether there is any value of n for which 4 raised to n ends with the digit 0. So one way of doing it is write all the possible numbers 4 raised to n, like 4 raised to 1, 4 raised to 1, 4 raised to 2, 4 raised to 3, and so on. But we see that there are infinite such numbers, and we can't go on expanding each number and then checking whether it is ending with 0 or not, right? That is not possible. So this is where fundamental theorem of arithmetic comes into light. So if we use the fundamental theorem of arithmetic, we can see that this 4 raised to n can be expressed as 2 raised to 2 raised to n, which is nothing but 2 raised to 2n. So what this means is that 4 raised to n is basically 2 into 2 into 2 into 2, 2n times, 2n times, and 2 is a prime. So as per fundamental theorem of arithmetic, there is no other way of expressing 4 raised to n but 2 into 2 into 2 into 2. That is the only way in which 4 raised to n can be expressed. So another conclusion that we can draw from this is that there is no 5 in the factor of 4 raised to n, right? It is only 2. There is no 5, 7, 8, any other number. There is only 2. But 5 is important because it is asking whether the digit ends with 0. And if a number is ending with 0, it has to be divisible by 5, which means 5 should have come as one of the factors of that number. But we see that in 4 raised to n, there is no other prime factor other than 2. There is no 5. So we can conclude that it will never end with 0. It will never end with 0. So without even expanding the numbers, without even seeing what the actual number is, we can conclude from the fundamental theorem of arithmetic that 4 raised to n is never going to end with 0. This is one of the application of fundamental theorem of arithmetic. In future, we will see some more applications. Till then, thank you for watching the video. I hope you enjoyed it. And please let me know any feedback or any particular topics that you want me to explain. And I will be happy to do it. Thank you and have a great day ahead.